Okay, today we shall be developing today we shall be developing GARCH GARCH 2.0 model, meaning that there is two arch but no GARCH. There is two arch but no GARCH. So that is called GARCH 2.0 model. So there is two arch but no GARCH. That is called GARCH 2.0 model, right? GARCH 2.0 model that we shall develop today. And we have the data. You can see all the data. BBR, okay. The data are here: BBR, BSR, IBR, and PBR. These are data. So I can make it zoom for you. All the variable, right? I make it zoom. You can see all the you can see I have the data, right? BBR, BSR, IBR, and PBR. What is called BBR? Bangladesh bond return. Then what is BSR? Bangladesh stock return. What is IBR? Indian bond return. What is PBR? Pakistan bond return. So I have four variables, and here I assume that all the variables are stationary, and if not we have to make it stationary, and then I can run the GARCH 2.0 model. But here we assume that all the variables are already stationary, so we can run our model. Okay, here from here okay, and here IBR. So as I told, we have four variables: BBR, BSR, IBR, and PBR. Out of these all variables, IBR is our dependent variable. IBR is our dependent variables. Okay, what I am doing, I am opening all the variables. Sorry. Open as a group, right? I'm opening all the variables. I'm sorry. So these are my variables: BBR, BSR, IBR, and PBR, right? And here we have taken data for 200 days return data. 200 days. So I go down, 200 days data, the return data. I'm going down, so 200 days. So until this, that is our sample size. 200 days data of these four variables, return variables. Okay. Okay, the question is that when we can run the arch model. When we can run the arch model. So there are two conditions. What are the conditions? Conditions number one, there should be clustering volatility. There should be clustering volatility in the residual. That is condition number one. And condition number two, there should be arch effect. and only then we can run the arch model or GARCH model. Arch or GARCH, right? But there should be two things. One is clustering volatility in the residual, that is number one, and number two, there should be arch effect after arch test. Okay, so we proceed one by one. First we run the model, and I told you, suppose IBR is the dependent variable, then I take the constant and PBR. Suppose I run this regression model, IBR, C and PBR. Then we can check all these two things. One is clustering volatility and the second one is the arch effect. Okay. So I go to a quick estimate equation. I do it. And here I put the variables IBR, C, then PBR, right? What is IBR? Indian bond return. What is PBR? Pakistan bond return. And our sample size, I take 200 days. See, 200 days, right? Sample size. So that is our model. So we can estimate the model. Okay, what I do, I make it zoom so that you can see better. You can see that is our model, right? That is my model, you can see, and that is the sample size, right? So I can run it now. Okay, so I press OK. Okay, this is the estimations of our model, and dependent variable is IBR and independent variable is PBR. Okay, now we check the residual of this model. So that is residual. Here you can see, I click here. So that is the outcome of the residual of 200 days. You can see from here. So this is 200 days. It is day 1, it is day 200. All right. 200 days volatility. Okay, from here I can see, suppose this is day 1 until day, suppose here, from here to here, around 30 days, right? From here to here, 30 days. What is happening here? That is what is happening here. I just check here. Okay, here the periods of low volatility is followed by another period of low volatility for a prolonged period, suppose 30 days, right? But from here, from 30 days until here, right? 30 days until 100 days, right? About 100 days, period of high volatility is followed by period of high volatility for a prolonged period. Again, from here to here, here to here, period of low volatility is followed by period of low volatility for a prolonged period. And from here to here, that means from 150 days until 200 days, so period of high volatility is followed by period of high volatility. So we can suspect that there is a clustering volatility. There is a clustering volatility, meaning that we can run the ARCH model. Why? Because period of low volatility is followed by period of low volatility for a prolonged period. At the same time, period of high volatility is followed by period of high volatility for a prolonged period, and that is called clustering volatility. So probably we can estimate the model using ARCH model, but we can double check it by using ARCH test whether there is ARCH effect in the residual or not. That we can double check before introducing ARCH model. Okay, how to check? I go to view, then residual diagnostic, then I go to heteroscedasticity test right here. Then I choose ARCH effect and I choose number of lags 1, right? Then I press OK. Okay. So it is the ARCH test. ARCH test is here. Observed R squared, p value. How much it is? It is less than 5%. The p value is less than 5%, meaning that we can reject the null hypothesis. What is null hypothesis? That there is no ARCH effect. That is the null hypothesis, but we can reject it because the p value is less than 5%, meaning that there is ARCH effect. So we can easily run the ARCH model or GARCH model, and because there is clustering volatility in the residual, at the same time there is ARCH effect. So we have all the validity to run the ARCH or GARCH model, and here is our plan to develop a GARCH model, GARCH 2.0 model, meaning that there will be two ARCH effect but no GARCH effect. That is our model. Okay, that we shall do now. Okay, so here we are developing, because the residuals are behaving clustering volatility. We have seen clustering volatility and we have seen the ARCH effect in the residual. So we can easily run ARCH and GARCH model. That we shall be doing now. And our plan is to develop what is GARCH 2.0 model. 2.0 model, meaning that there is two ARCH effect but no GARCH effect. That we shall be doing now. And here IBR should be our dependent variable and PBR is our independent variable, and that we shall do now. Okay, I go to estimate and from here I choose ARCH, autoregressive conditional heteroscedasticity, and here I put as planned IBR, C and PBR, right? That is our plan. And here there is that is called mean model. That is mean model, and that is variance model, right? One is mean model, and here is variance model. And here our plan is to develop GARCH 2 model, meaning that here GARCH I put 0 and here I put arch 2. You can see from here arch 2 and GARCH 0, meaning that there is no GARCH effect. And here the variance variables, right? Variance variable, I put two external variable such as BBR and BSR. What is called BBR? Bangladesh bond return. What is BSR? Bangladesh stock return. And the sample size is 200. That is here, right? 200. And suppose here I choose error distribution. Suppose I choose student error distribution. So that is my model set. Okay, I can make it big. I can make it big. That means I can make it zoom so that you can see better. I go to zoom here. Okay, you can see the zoom. See, that is the mean model, right? Mean, IBR, C, and PBR. And that is my GARCH 2.0 model, meaning that 2 arch effect and 0 GARCH effect. That is called GARCH 2.0 model. And here is 2 external variable, external effect, that is Bangladesh bond return and Bangladesh stock return. That is the external volatility that can affect the volatility of the Indian bond return. That is here, right? That is here. And here I choose student T distribution and the sample size is 200. So everything is set. Now I can go to OK to run the model. Okay, press OK. So the result has come up. So dependent variable is IBR and I have chosen student T distributions. And it is the GARCH model C3, C4, C5, C6, C7. So here it is the mean model. The first one is the mean model, and the second one is variance model. Actually the variance model is the GARCH model. The variance model actually GARCH model, that is here. You can see from here, right? That is GARCH model. GARCH model and the variance model is the same. So you can see from here, actually C3, actually this one. C4, this C4 actually this one. C5 actually this one. That is C5. And C6 actually this one. C7 actually this one. And this one is C, actually C1, this is C2, C3, C4, C5, C6 and C7.
C8.
And GARCH model actually start from C3. C3 means actually this one, the constant. C4, C5, C6 and C7. Okay, so this is my GARCH model. So now here I said I have no GARCH effect. Here you can see there is no GARCH effect. Only there is two arch effect. So this is arch 1, this is arch 2. So I have two arch effect here, and there is no GARCH effect because it is GARCH 2.0 model. Okay, so we talk about GARCH now, GARCH 2.0 model. Okay, first we talk about receipt, this one, that is arch 1. Is it significant? No, because the p-value is 9.10%, so it is not significant. Okay, what is called arch? Arch means that refers to previous period's squared residual. That is arch, or I can say previous days bond return, previous days information about the volatility of the Indian bond return. So that is the arch, and this is arch 1, and second one is arch 2. It is significant? No, it is not significant because the p-value is 65.46%, meaning that arch 1, arch 2, none is significant, meaning that previous days information cannot influence the volatility of the Indian bond return, that is IBR, right? So this GARCH actually is what? This GARCH means the dependent variable here actually variance of the residual of the Indian bond return. Okay. Variance of the residual, right? And that is we have derived from this mean equation. Actually this GARCH dependent variable, how to get it? This one we have derived from mean equation, that is this one. So in other way I can say this GARCH means actually the variance of the residual derived from mean equation, from here, right? The variance of the residual derived from mean equation, that is here, this one, that is here. Okay, the question is that from here I can see arch, what is receipt 1 and receipt 2? These are the internal causes that can affect the Indian bond return volatility. Internal causes, internal return, internal information that can influence the volatility of the Indian bond return, and they are insignificant. You can see from here they are insignificant. That means internal volatility, internal information, internal causes, internal reason cannot affect the Indian bond return volatility. Okay, wow, but what about external volatility? Whether external volatility can affect Indian bond return or not, that we can check. such as BBR. BBR is the external shock, outside shock. What is BBR? Bangladesh bond return. Okay, the question is that whether Bangladesh bond return, whether the volatility of the Bangladesh bond return can influence the volatility of the Indian bond return. That is the question. And here the BBR, is it significant? Yes, it is significant because the p-value is less than 5%, meaning that external volatility, which is BBR, can influence the Indian bond return volatility. So that is, we can see from here. Then what about another external shock? Another external shock such as BSR. What is BSR? Bangladesh stock return. Does it affect the volatility of Indian bond return? No, because the p-value is 8.69%, meaning that Bangladesh stock return cannot influence the volatility of the Indian bond return. Okay, that we have seen here, and then we can check. So meaning that in this model, internal shock such as arch 1, arch 2, these two cannot affect the volatility of the Indian bond return, but external shock such as BBR can affect the volatility of the Indian bond return. Okay, now we can check again whether arch 1 and arch 2, these two jointly can affect the Indian bond return or not. That means here we can do joint test. Joint test we can do. Okay. And the question is that what is this one? Recede lag 1. Recede lag 1 means C4. Right? We can see. And recede lag 2, this one is C5. So C4 and C5. Whether C4 and C5 jointly can influence the Indian bond return or not. Which are the internal shock, internal reason. Okay, so how to do it? So to check it, we have to do world statistics. What statistics? World statistics. World. W-A-L-D. World test. We have to do world test. That is called joint significancy test. Joint significancy test, right? And that is C4. The hypothesis is C4 equal to C5. That is the hypothesis. C4 equal to C5 equal to 0. So that is world test, right? Okay. So I proceed with my test. I go to view, then coefficient diagnostic, then world test. It is here, world test. So I put here C4 equal to, I've done a mistake, C4 equal to C5, equal to 0 or not. That I want to check, right? C4, C5 equal to 0 or not. You can see from here. Okay, we can do it. C4. So I can make it zoom for you. You can see better. I make it zoom. You can see this is the hypothesis I set. C4 equal to C5 equal to 0 or not. That we want to check. Okay, so I press OK. So that is the wall test equation, right? Probability, chi-square, and the p-value. What is the p-value? Okay, what is the null hypothesis? The null is C4, C5 equal to 0. Meaning that is the null hypothesis. C4, C5 equal to 0. That means C4 and C5 jointly cannot influence the dependent variable, which is Indian bond return. Or in other way, ARCH1 and ARCH2 jointly, ARCH1 and ARCH2 jointly cannot influence the volatility of the Indian bond return. So that is the null hypothesis. And here, what is the p-value? 17.65%, which is more than 5%. So here, we cannot reject null hypothesis. We cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that C4, C5 equal to 0, meaning that ARCH1 and ARCH2 jointly they cannot influence the volatility of the Indian bond return. Meaning that in other way, internal effect, internal causes such as ARCH1 and ARCH2 jointly do not influence the volatility of the Indian bond return. So that we have seen here from the Walls test. Sorry. So why this model? It is our model, right? Okay. And we want to check now whether our model has arch effect and whether our model has serial correlation or not. That means we want to check whether GARCH 2.0 model that we have developed has arch effect or serial correlation or not. Okay, we check one by one. I go to view, then residual diagnostic, then arch test. I click here, and here I choose arch, and here I choose lag 1, right? I click here, arch test, right? Arch test, observed R square, p-value 83.57%, which is more than 5%. So what is our null hypothesis? The null hypothesis is there is no arch effect, and we cannot reject it. We cannot reject it, meaning that there is no arch effect. So we are happy about the model. This model has no arch effect. Okay, then we check serial correlation. I go to view, residual diagnostic, then I choose correlogram, squared residuals, right? This one. I choose 36, right? Okay. And here you can see the p-values, right? P-values, that is the Q statistics and p-value, right? You can see the p-value. P-value are more than 5%. p-value are more than 5%, meaning that we can say that we cannot reject null hypothesis. What is the null hypothesis? The null is there is no serial correlations. That is the null hypothesis, and we cannot reject it because the p-value is more than 5%. You can see the p-value, right? More than 5%. So meaning that this model is free from serial correlations. So what is the decision? This model has no serial correlation. This model has no arch effect, but this model arch 1 and arch 2 is not significant, meaning that internal shock cannot influence the volatility of the Indian bond return, but external shock, there is one variable, that is external shock, which is what? That is external shock, which is BBR, that is Bangladesh bond return. The volatility of the Bangladesh bond return can influence the volatility of the Indian bond return. Yes, that means BBR can influence the Indian bond return. So that means there is a external influence on the Indian bond return. So that is the end of the story. Thank you for being with me for a while.